In this video, we will discuss the concept of elasticity as it applies to supply and demand curves. We'll begin by discussing the price elasticity of demand, which measures how responsive or sensitive quantity demanded is to a change in the price of the good itself. This number is always negative because of the law of demand, so generally we ignore the minus sign. And what we're going to do is we're going to compare a measure of the change in quantity demanded to the change in price. We can't use the change in levels because that depends on the unit in question. So if I change how I measure quantity or price, that changes that numerical difference in quantity demanded or difference in price. It also depends on the good in question. Cars, for example, are on a very different scale than bubblegum. So when we do the price elasticity of demand, we're going to use the percentage change in quantity demanded divided by the percentage change in price. By comparing percentage changes to percentage changes, we will remove the dependence on units and the kind of good, so we can actually do comparisons of elasticities between very different forms of goods. So we can compare the price elasticity of demand for baseball tickets with the price elasticity of demand for ramen noodles with the price elasticity of demand for cars, for example. And we interpret the price elasticity of demand in light of a couple of major benchmarks. The first one is what happens when the elasticity equals 1. Well, since the elasticity is a ratio of percentage changes, that means that these percentage changes are equal. So a 10% increase in price results in a 10% decrease in quantity demanded. And we'll call this value unit elastic. So whenever the elasticity of demand equals 1, it's a unit elastic part of the demand curve. What if epsilon's bigger than 1? Right? What if epsilon's 2, for example? Well, that would mean that this 10% increase in price results in a 20% decrease in quantity demanded, and we call that elastic. So demand curves are elastic when the quantity response is bigger than the price response. And what if epsilon's less than 1? 0.5, for example. Well, that means that our percentage change in quantity is smaller than our percentage change in price. So a 10% increase in price will result in a 5% decrease in quantity demanded. And we call this kind of a demand curve inelastic. We will use these concepts later on when we look at the pricing decisions of firms and how they depend upon the demand elasticity. Next, we're going to turn to another kind of elasticity of demand, in this case, the income elasticity of demand. So how does the demand curve and quantity demanded change as I change income, holding all else equal? So we define the income elasticity of demand as responsiveness of quantity demanded to changes in income. We're going to measure it using the percentage change in quantity demanded divided by the percentage change in income. And generally, we calculate this value using what we call the midpoint formula. So when we calculate our percentage changes, we're going to be dividing by the average value, not the either endpoint of our changes. This income elasticity is going to divide goods into 3 groups. They're going to be inferior goods. These are goods for which the income elasticity of demand is less than 0. So as income goes up, quantity demanded is going to go down. Necessities, these are goods with an income elasticity of demand between 0 and 1. So as income goes up, quantity demanded goes up as well, but not as much. So you can think about things like food, right? As your income goes up, your quantity demanded of food will go up as well, but maybe not as much as your income does. Next, we have luxuries, and these are goods for which your income elasticity of demand is greater than 1. You can think about luxury cars, for example. Right, a 10% increase in your income may not increase your demand for luxury cars by 10%. It may increase it by much more, by 30, 40, 50%. And in both cases, for necessities and luxuries, we also call these kinds of goods as normal goods, because any good with an income elasticity of demand that's positive is going to be considered a normal good. Quantity demanded for that good goes up as income goes up. Next, let's turn to the supply side and think about the elasticity of supply. This is going to be a measure of how responsive or sensitive quantity supplied is to a change in the price of a good. So it's the flip side of the price elasticity of demand. Again, it's going to be calculated using the midpoint rule as the percentage change in quantity supplied divided by the percentage change in price, and it will always be positive because of the law of supply. As supply curves get steeper, right, as they start going up faster, we talk about supply being more inelastic. And as supply curves get flatter, more closer to the horizontal, we call them more elastic. And we can use the elasticity of supply to understand how prices respond to demand shocks. So let's imagine a city that attracts lots of new residents, creating an outward shift in demand for housing. If the supply of housing is elastic, i.e. flatter, then the increase in the house prices will be smaller. So you can see that here with how this relatively flat supply curve results in a small price increase from 6 to 7. On the other hand, if the supply curve is more inelastic or steeper, then the increase in prices will be larger, as illustrated by the second supply curve, and the price now rises from 6 to 9. So understanding the elasticity of supply is really important for understanding how prices will respond to demand shocks. So what affects the supply curve and the elasticity of the supply curve? We've already seen supply shifters in the supply and demand video. Here, we'll think about the elasticity itself and how it's governed by two things: production possibilities, so can you use resources in alternative ways or resources available, and storage opportunities. So you can imagine first that there may be constraints in your ability to produce new supply that would create a more inelastic or steeper supply curve. On the other hand, if you could freely store and then resell a product, that would make a more elastic supply curve. And you can think about that also in the context of, for example, flowers and candies at Valentine's Day, where the supply curve for flowers is more inelastic because they cannot be stored as easily as candies can. And so therefore we would expect to see a larger run-up in prices for flowers than for candies in the lead up to Valentine's Day.